So I thought that I would create a video solution key for this particular quiz. The idea of apportionment is trying to figure out a fair way of allocating out whatever it is that you're trying to apportion, whether it be, example here, you're trying to apportion out city high council seats. An example in one of the notes, there was a car dealership, Congress seats. There's lots of different ski resorts, so divvying out skis, things like that. So we're just trying to figure out a fair way to do that. There are two ways that I presented in the notes, and that was Hamilton's method as well as Jefferson's method. We'll start here in the first example with Hamilton's method. And what I'm looking at here in this example is J.R.R. Tolkien's Middle-earth. And in Middle-earth, there are several realms, and 3 realms that I'm looking at here: Gondor, Eriador, and Rohan. And they were trying to create a high council so that they could have, nice protection, trade, cultural exchange, keeping themselves protected, essentially. All right, so the math behind what we're trying to do here. So the first thing that you need to always find is the standard divisor. And if you look on your formula sheet, the standard divisor is defined as the total population divided by the number of items to be allocated. And so here you can see that the total population is 201, and that would be in thousands, but as I said up here, you don't have to convert that to thousands, so just keep it at 201. And then you divide it by the number of items that you have to allocate. Well, here you have 10 seats on that high council. So I'm going to do 201 divided by 10, and of course if you divide that out, you're going to get 20.1, and we're just going to keep that. So then the next thing that you do, as it states here in Part B, calculate the standard quota for each realm, and I've got a row for you to do that in the table itself, and you're going to round each of those to the nearest hundredth. So in this first one, I'm going to take 94.7 and divide it by 20.1, and that's going to give you 4.71. Next one, Eriador, 72.6, divide it by 20.1, and that's going to give you 3.61. Rohan, 33.7 divided by 20.1, that's going to give you 1.68. Total here is of no consequence. Then, according to Hamilton's method, you always round these down, so essentially you just go back and take all of your whole numbers. So this would be, in this case, would be 4, 3, and 1. Now add this across, and you have 4 plus 3 is 7 plus 1. I have 8 seats. So you've got 10 seats to give out, but at this point you've only given out 8 seats. That's where the problem is. So we want to figure out, according to Hamilton's method, he says those additional seats is based upon the fractional remainders. The fractional remainders are just going back and looking at the decimal values for all of your standard quotas. So I'm just going to take and bring those down. So here you have 0.71, 0.61, and 0.68. And again, that entry there means nothing. Since I have 2 seats left over, because I have 10 to give out and I've only given out 8 at this point, since I have 2 seats left over, then those with the highest fractional remainders in this row are going to get an extra seat. So as you can see, 0.71 would be the highest and 0.68 would be the next highest. So each of those are going to get an extra seat. So instead of it getting 4 seats, it's going to now get 5 seats. Eriador is going to stay the same at 3, and Rohan is going to go up from 1 seat to 2 seats. And if you notice now, as you add across, 5 plus 3 is 8, add 2 more, and you've got 10 seats. All 10 seats now have been allocated, and that would be using Hamilton's method for apportioning out those 10 seats. Okay. So if we flip it over and we look at Jefferson's method for this exact same problem. So essentially what Jefferson's method says, do Hamilton's method. And if his method gives you all of your allocated, if you're apportioned everything that you're supposed to with Hamilton's method, then you're good to go. If not, then you have to do then you have to work with what are called modified divisors. And so this first row here that you see is just a repeat from I should say these first 2 rows are just a repeat of Hamilton's method. So we take basically 94.7 and divide it by the standard divisor of 20.1, and of course that gave us 4.71. I'm taking this 72.6 and I'm dividing it by the 20.1, And of course, I'm just going to get that 3.61 again. 33.7 divided by the 20.1, I'm going to get 1.68. Again, that means nothing. Round down, you have 4, 3, and 1. Add that across, you have 8 seats. What that means, Hamilton's method doesn't work, but that's the basis of Jefferson, okay? I know we had already done this, but if you'd started from scratch with Jefferson's method, you needed to do that first, because if all 10 seats had been allocated, Jefferson says stop right there. But here, because all the seats had not, we go now with a new modified divisor. And I picked the divisor for you, and I said, now go with 19. So what that means now is I take that 94.7 and divide it by 19. And I'm still going to be rounding to my 2 decimal places, so that's going to give me 4.98. Then I'm going to take the 72.6, coming back up, always using those original numbers, 72.6, again, divide it by 19. That's going to give you 3.82. Then take your 33.7, divide it by 19, and that's going to give you 1.77. Again, that entry there won't mean anything. Round them down. Use your whole numbers. So 4, 3, and 1. I haven't helped myself. I still have only allocated out 8 seats. I need to get all 10. So now it says, okay, here's a new modified divisor. Go down to 18. Again, go back to your original populations. Now divide each of those by 18. So 94.7 divided by 18. And that's going to give you 5.26. 72.6. Going back up here, 72.6 divided by 18, and that's going to give you 4.03. 33.7 divided by 18, and that's going to give you 1.87. Round all of those down, picking your whole numbers, 5, 4, and 1. Add across now. Of course, that's all 10 seats being allocated. That would be how Jefferson would have allocated out those seats. So all that I asked down at the bottom there was about a comparison. I do apologize for the typo. It just should have said, to compare Hamilton's method and Jefferson's method for receiving the seats for the High Council. A copy and paste error there. But nonetheless, I'm hoping that you're opening up, at the very least, the notes for these sections and the solution key. I would hope even more so, though, that you open up these videos, because the videos really do talk you through how to solve them. And if you had seen through the video what we were doing there, and also through the solution key, what I mean by comparing is just looking at your 2 final rows. And as you can see for this particular example, Hamilton and Jefferson both gave Gondor 5 seats to the High Council. Where the discrepancy came in was between Eriador and Rohan. Hamilton gave 3 seats to Eriador and 2 seats to Rohan. However, Jefferson gave 4 seats to Eriador and 1 to Rohan. That's all that I was looking just for. It was just that, that simple little written out comparison of the 2 methods and how they were, dividing out those seats, differently. And it doesn't always have to be different. You did see one of those in the notes. So I hope this helps. If you're still having trouble, please come see me, call me, email me. I can definitely try to do the best I can at helping you get through this. Thanks a lot.